Turn left.
Good morning, everyone.
Good morning.
Morning.
Yeah, it is our last regularly scheduled call of the year. Or, well, not the year. Where is that? Oh, yeah. Yes, it is. Okay, we're against the next 2 meetings. Very good. Okay, today Fabrizio has another update for us on the evidence binding discussion. I'll let you take it away.
Yes, let me share my screen. Good morning, everybody. Please let me know when everybody can see the screen, so I'll start talking.
You can see it.
All right. So today I wanted to discuss. Thanks, Jeff, for giving me the opportunity to discuss what we kind of like are going through with the CWT, the heat binding for SPDM. So how we can bind CWT token for SPDM. The requirement we have is that, like we said, the heat shall be represented as a CWT, which we already discussed in the past, which is a CBOR web token. The heat can have two representations: a JWT, which is JSON, and a CWT, which is CBOR. But we decided for SPDM to have it to only allow the CBOR web token. And we want to make sure the solution should be retroactive for SPDM 1.2. So we need to make sure that even with the current existing spec with 1.2 or 1.3, we should be able to represent a hit. And there are other couple of requirements that the CWT should have its own attestation key, AK, that should be distincted from the identity key. And the fourth requirement is that the SPDM itself, the SPDM binding itself, the SPDM specification and the protocol itself should only respond to get certificate to the certificate chain associated to the SPDM transcript EK. What that means that we don't wanna, like in general, SPDM to care that much about the CWT. We want to try to decouple as much as possible to avoid issues between the coupling and making assumption in the SPDM spec. So as far as concerned, 1.2, and things might change a little bit when we go through 1.4, when we may have more knobs for tuning the SPDM, for tuning the CWT itself. But for 1.2, in order to guarantee the backward compatibility, we want to make sure that the CWT token can have its own representation and should not be really coupled with SPDM spec. So that means that we have a couple of updates. One of all is that the requester share requests it at slot F0. And for this, I also updated the suggestion on the OCP attestation spec. And why F0? F0 has been allocated by the NTF SPDM workgroup and retroactive for 1.2. The responder should set the signature request bit in parameter 1. So this is something that kind of like a bit of a coupling we have it right now. And the reason why we have this coupling is because if you don't set the signature request, even for the SPDM transcript in the SPDM 1.2 spec, you are not allowed a role to introduce a nonce. The nonce is fundamental for the heat because otherwise you will not get freshness of the measurement. And when I say freshness, I mean freshness of the signature of the measurement. So for this reason, we might need to, it's required that that is a should requirement, not a shall requirement, definitely, that the requester will set the signature requester bit in the parameter 1 when it does get measurement. Otherwise, the nonce will be set to 0. And yeah, this will be like not really probably helpful to the verifier. Is any question till now?
I got a couple of questions on this slide.
Okay, sure.
One, on the third and fourth bullet, I see eat nonce is wrapped in a parentheticals. I'm wondering what those signify.
Oh, sorry. No, it's the CWT. I call it eat nonce. It doesn't mean anything. Like I'm sorry if this caused confusion. This is not really relevant. The fact that it's in a bracket, the fact that it is in a parenthesis just means that the parameter inside the CWT is called eat nonce, just to indicate the naming convention of the claim for the CWT.
So got it. Okay, so the third bullet makes sense. The fourth bullet though, like responder shall set the CWT to 0. I think nonce in CWT.
So yeah, the sheet said the CWT nonce, so probably better to do this way. The CWT it nonce to 0 if the signature requester bit is not set.
Okay. My last question is, why is the fourth bullet required?
Oh, because otherwise we can put a should instead of a shall here. The reason why I put a shall is to basically guarantee like consistency of this measurement claim when like the nonce is not specifically set by the requester. So what does it mean? If the signature request is 0, the SPDM requester has no way to introduce to pass a nonce to the responder, right? Because by looking at the spec, the SPDM 1.2 spec, the requester is only allowed to send a nonce to the responder when this bit is set. Otherwise, the nonce length field length must be 0. Since not long, yeah. So that's why, in order to, we just want to make sure that if the verifier will see a known value which is 0 when when it's not set by itself, like just to make sure that the verifier can introduce a policy that if you see it nonce equals 0, it means that it's an invalid CWT or something like that, just to make sure that that nonce, it's a specific nonce value that has not been configured by the requester.
Okay, I would suggest something just to clarify that a little bit for people like me who wasn't aware of that. Maybe set the eat nonce to 0 if the nonce was not provided, e.g., if signature requested bit is not set.
So there is a problem with this option, which is, so this is Jeremy O'Donoghue from Qualcomm. The eat nonce claim explicitly says that an eat nonce shall have 64 bits of entropy, and 0 kind of doesn't.
Oh, yes. Yeah, 0 means 64-bit 0. So this should be an array of 64-bit 0. Like we can clarify that as well, if that is the concern.
I think I'm still concerned that the word entropy is included in the shall. And I think a string of, it is a challenge for me to believe that a string of 64 bits of 0 represents entropy.
So, well, that's interesting. So it sounds like that you're not allowed to have a valid eat unless you put 64 bits of strong entropy into it when you made the nonce.
That's not correct. All claims in entropy attestation token are optional. So if you do not have a nonce, you are supposed to not include the nonce claim. If you include a nonce claim, it is supposed to be reasonably random. Sorry, to explain, I'm one of the editors of the Rats Eat internet draft. So
thanks for coming.
So I think this is not an appropriate solution. I would suggest that the eat nonce claim is not included if you don't have a nonce.
That will work as well. If we get just not including, that will be fine. I can replace that and say it shall, let's say, shall not include, we can put shall not include it nonce if in the CWT. That will work as well.
There was
Will
one
that be-
word I was missing. It sounded like eat nonce frame. Was frame the word?
Sorry,
Claim.
the word is claim.
Claim. Thank you. Thank you.
Will
Can you
that
say
be
that here?
yeah, will
The
that be a
nonce claim?
problem? Yeah.
Yeah, that's correct. And that still leaves you with a valid token.
Okay. Yeah. So yeah, since that's a good point. Actually, I appreciate the suggestion because actually, for the it perspective, there is not a minimum claim set that must be included. So having not having the e nonce will still be a valid CWT. So that will work as well and will solve the problem in a more elegant way. I appreciate the suggestion. So if there are any question, I'll move forward to the next slide.
Yes, I'm just typing in one bike shed suggested chat text here. You can put it in whenever.
Sorry, I missed that, Jeff. What did you say?
Sorry, I just put in chat just like something that would help me better understand the connection between signature requested bit and nonces.
Okay.
I was not aware of the rule that you can't actually like send a nonce at all if you don't ask for a signature. So this would help for that for.
Yeah, I added here in yellow, but maybe maybe it was not.
Oh, gosh, you had it right there, and I just didn't read it. Okay, huh. Never mind. Okay, didn't read. All right, please carry on.
Okay, so this is how, just for the binding spec itself, it says how the CWT measurement block will look like. It will be index equal F0. I don't know why I say depends on the request, like just put index equal F0. The measurement specification is E1, which means NDMTF spec. Then the measurement size is the size of the payload, and the measurement itself is the payload. And for the DNTF measurement, you have the measurement type as a raw bit stream, and the value size is the size of the CWT. Then depends on your CWT how big it is. This is in bytes. And then here you have the values, actually the CWT. And here you will have the how the CWT it will be crafted. So one thing we want to do it, at least for 1.2, and we discussed with Steven and Ned Smith as well, that this can be kind of like optional if we add the forger bit when we start for 1.4, but for 1.2, we want to have the certificate chain included, like always included in the it as well. And where the certificate chain will go in the unprotected area of the CWT, of the it. So you will have a certificate chain in the protected area of the CWT always, and then you have the it nonce here, the SPDM nonce, and then you have the measurements into the represented as concise evidence CBOR tag, like we discussed, like in the previous session. But what the important portion here is that this will include the it itself will include the certificate chain that where the leaf of the certificate chain signed the whole cause structure. So the it is signed by the certificate chain, by the leaf portion. So the leaf node of this chain signed the CWT. And we want to make sure, like we said before, that this certificate chain shall be different of the one reported by get certificate. So we want to make sure that the same signature signed it doesn't sign the transcript, if that makes sense.
Sorry, Fabrizio, you mentioned that the certificate chain inclusion in the e-token is a requirement.
Yes, and the reason why is that at least for 1.2, like this is was a topic of discussion with Ned and Steven a few days ago. We met, and what we came up with is that for SPDM 1.4, we can ease this a bit and say maybe the SPDM 1.4 can carry an extra bit in the parameter one, saying, hey, want to include or not this into the it. But right now, with SPDM 1.2, we don't have such flexibility. So we kind of like sacrifice a bit the performance, you want to say. We're having always a bigger payload, but we don't sacrifice the robustness of the token itself. Like we need to know where the certificate chain is included, and the certificate chain, we don't want to tie with the get certificate itself, because the get certificate itself will report a certificate chain that signed the SPDM transcript, which might have some, and if the transcript and the token will sign this, will be signed by the same key, this could have some security vulnerability for obvious reasons.
Yeah, no, that makes sense. I mean, there's no question that the signing key and the lease certificate, right, makes sense that you know, they're different, right, because of the reuse of key, right? But it is very likely that the remaining portion of the certificate chain is going to be the same, right? So that's how, you know, we will probably implement it, right? We would share the same certificate chain with two different lease certificates, right? So this, you know, may not always be necessary. I understand backwards compatibility, but I'm wondering if there is a way that we can make it such that I can provide a partial cert chain.
So we can make something like this. Will that work? Instead it is. So you have like at that point, you don't know, you are not prescribing here how big should be the cert, because you have a valid point, Eduardo. I agree with you. Like maybe your verifier doesn't need the full certificate chain, but if you put a should be the root CA, at that point you will suggest to have the full certificate chain. But if you need to, because for your specific reason, you don't need to have the full certificate chain, because probably the trusted anchor of the verifier is an intermediate.
It's very likely the trust anchor chain is going to be the same. I think this makes sense. I think this would enable that use case.
Any other? Yes. That was a very great feedback, Eduardo. First of all, I really appreciate it. There are any other questions? Will this work for everybody? Like the end goal here, Eduardo, like for this is something not feasible for probably 1.2, but in general, what we want to enable with when we move to SPDM 1.4, this is at least what I'm envisioning that I have in mind. That maybe not work for everybody, but I feel like my end goal is to having a verifier being able to simplify as maximum the SPDM protocol. And at the beginning, it just can run VCA, means version capability algorithm, which are mandatory by the SPDM spec for kind of like a negotiation and establishing a session, and then just get measurement and get the hit. So at that point, the SPDM protocol will be simplified as minimum and still will allow a verifier, which is behind the TCP probably protocol, to remote verifier to appraise to an attestation report.
Yeah, no, that makes sense. I mean, I'm in agreement there. As long as we have the flexibility here to provide a partial cert chain, that will be fine. You know, from my perspective, I don't know what everybody else thinks, but appreciate that.
Okay, so if there is no disagreement here, I will move with my last slide, which will talk. I don't know if it's really interesting for SPDM only, but it will be kind of like I want to show how a potential DP binding for SPDM to CWT will look like. And Jeff, this starts from a suggestion you initially gave. I just expanded a bit more. In case that your SPDM responder is behind DPE client, for whoever is familiar with, it will have access to its own DP context. Both the SPDM identity key and the CWT attestation key can be obtained by invoking the certificate key with different labels. And here I put the two suggested labels, which we can bring into the binding spec. Then the identity key can use exclusively to be signed SPDM transcript, and the CWT attestation key can be exclusively used to sign the COSE structure. And the identity key, as you say, is retrievable by SPDM get certificate command and attestation key by get certificate command. So we kind of like with this binding, we introduce something like parity like between the certificate chain and the CWT. What does it mean? That imagine that you get certificate at slot 0, using slot 0, you are getting, when you do get measurement, you're getting the CWT. Like Eduardo was before also hinting to, this first part of the certificate chain will be actually equal between the get certificate and the CWT. And the only thing that is different will be the DP certificate, which one will include, this one will include attestation key, this one will include identity key. So that will work very well when you kind of like want to only retrieve a partial certificate chain, because at that point you can just include the certificate into the it. Any questions at this point? Hello?
I hear you.
We can hear you.
Yeah, okay, perfect. I just want to make sure everybody could hear me, and like I was not getting mute by the headset. So that what I wanted to present, Jeff. I wanted to know, the first ask I have is for everybody, if everybody will be fine with that, because my plan will be to, so they were coming like I didn't listen to the slide, but there are this is the plan here. I wanna add this at least up to here, up to slide 5, all these prescription solution on the OCP attestation specification. Then slide 6, I was working with, I will work with Nesmith to add it on the TCG. DICE concise evidence spec for SPDM, and Steven will help. I think Steven is here. He will help to create a presentation for the DNTF SPDM work group, which will be a bit less prescripting than definitely the OCP attestation spec on how the binding for SPDM and CWT will work.
Yeah, and I also think for OCP attestation, we should be looking at what kind of claims we want to see. So are there any shall claims? Are there any should claims? Because CWT and EAT have a lot of different claims that can be there. And so if we just leave it up to everybody, then there might be a little bit of chaos. But if OCP attestation can narrow things down, that might be good. So that's a very valid point, Steven. So my point I want to try to make here is that the only two claims that are a shell are the nonce for obvious reason, and the measurement, which will include all other claims in the concise evidence format. Like the concise evidence format will have like we discussed before, will have a triple identification of the measurements in environment map, measurement map array form. All right, so those are, I consider those like really device specific or maybe vendor specific measurements, but EAT has more general claims that it's possible OCP attestation could require. I mean, you got things like the unique identifier, the OEM identifier, stuff like that.
Yeah, that was my point. All those information can be included into the concise evidence. And the reason why I want to include in the concise evidence is because those information that in concise evidence will have the same format as the quorum. So the main point of using the EAT is to try to find one-to-one mapping with what is the quorum itself. That's at least a way I see in mind, but I'm open for feedback initially.
I mean, are the EAT folks on board with that, or the RATS folks? Because I mean, there's a ton of claims in EAT.
It's not how I would have used RATS or used EAT. It's certainly not how we intended it in the design. I would probably, I mean, the way that we tend to look upon this in products that are on the market today is that the measurements are very useful for telling you that something is wrong, but they're not always very useful for telling you what is wrong. And so it is certainly commonplace to have the OEM ID. It is commonplace, unless there are strong privacy reasons not to do so, to have a UEID claim. It's quite common to have information like uptime or boot counts and the like. So those are commonplace, and as far as the rest with co-run, we haven't used in any product that we put together EAT with co-run, largely because we don't currently make any use of the message wrapping, the conceptual message wrapping. That's too early stage for us. So it's for devices that use EAT today, and Qualcomm would not be the only ones. Certainly, it is used in certain places in ARM's PSA products, for example. We tend to make more use of EAT claims rather than the conceptual message wrapping. The CMW has its place, but it's obviously in an early stage, so tricky.
So I have a question. So I have no problem to include other claims if folks think they are required. But my question: how would you use those claims? And if, like, what's the usage a verifier will do all those claims? And I will find policy for those claims. So where you find the reference measurements for those claims. So like usually the coding, the reason why I was thinking why I was thinking on the measurement, because the measurement will map with what the coding will provide, right?
Could do, yes.
So like when you talk about other claims in here, how those claims will be, how do you envision those other claims to be consumed by a verifier?
So, for example, if you have a verifier which is supporting products that come from many OEMs, perhaps because you have a verifier that is serving a reasonably large set of devices, then you might well use the OEM ID claim as a mechanism to select the correct set of reference measurements.
Okay, so you are thinking kind of like those extra information as a metadata to get to the measurements?
Yes.
Okay, that's a very valid point. So, Jeremy, if you can help me identify offline too, what do you think could be useful claims outside of the measurement? I will appreciate. I will include those in the spec.
Yeah, I can certainly try to help you with that.
Oh, perfect. I'll appreciate that. Yeah.
I mean, there are some claims which are, I think, going to be useful in designing verifier that supports multiple OEMs, multiple devices and models and so on. There are other claims which may be useful in debugging, and those are a little bit more difficult to assess because they tend to be a little bit more OEM specific. So there are some areas where the choice to include or not include a claim may not directly affect the design of a verifier, but they may help you to debug problems when they are detected.
Perfect. Yeah, I think that's very good, Jeremy. I was probably blindly looking at the heat just as a way to get to the measurement and to perform a appraisal policy against an authenticated quorum. Yeah, but I see your point. All these valid claims, they can help you identify the measurement, probably the measurement set with the reference value, and so the valid quorum maybe, and it can also help you debug issues in case of problems, which is kind of like we need to be careful, like, because like in for security purpose, like we need to make sure that those debugging information will not probably leak something of the device state that you don't want to be getting public, like you don't want to put in clear into the heat. So we kind of like we need a next level discussion of what should be a shell and what should be a should of those claims into the OCP attestation spec. But I'm on board on that with that.
So at the risk of being devil's advocate, I kind of want to voice support for what you've already done here. So the CWT as just a wrapper for concise evidence, because what that does is by minimizing the set of RATS specific claims you have in the CWT, you minimize the number of different specs and claims for CWTs the verifier needs to know about. So if what you are providing to a verifier is just a wrapper around concise evidence, I'm less sensitive to RAT specific claims versus DICE CWT specific claims versus some other spec that hasn't been written yet around CWTs. The less I need to know about the magic numbers inside this thing, and the easier it is for me to get the concise evidence out and to be able to use that to verify, the better, in my opinion.
That was the original intent, Dennis. That's why I just inputting the minimum, like the nonce, which is used for freshness. I cannot not include a nonce, and then a CWT, which is for the include basically the payload that need to be verified. But if other folks have other, like, more familiar with me with the RATSIT, like, and having like thinking that to put the extra support for the CWT claims, for I'm on board with that. Like, we may be like, what I would say, Dennis and Jeremy, what we might add all these. So my point is that we can add these as a share requirement. They must be there, and all other claims that you are suggesting, Jeremy, as a should. So we still have the capability to add those claims if you need to, but for a minimum verifier that just want to parse the concise evidence and take it against the quorum, that will be just enough, if that works.
Yeah, that works. The way I was thinking is that it might make sense to identify a small set of EAT claims, explain how I think they might be useful in the design of a system, and then this is exactly the right working group to say yes or no.
Okay. Yeah, so what I will do, like, probably the right way to do it is for me by the beginning of next year, just because the 2024 is wrapping up at this point, I will start putting this into the OCP attestation spec with what I think should be a shell, and you like, and probably like if you folks can take a look at the spec and the changes I'm making, you can start giving comment. We can start, even we don't need the meeting like this weekly meeting to start deciding what claim should be here, which claim should be there. We can using offline review it. And once we all agreed about a claim set and what must be here, in my opinion, like, and I agree with Dennis, that's why I was initially here, that we should have those two should be the only share requirement, but then we can have a sure requirement for UID or rather debugging useful information that an attester can include into the HIT.
Is there even like an OCP verifier spec I guess I'm a little concerned about trying to specify claims in the CWT without like the associated verifier spec about what's going to consume them. Because otherwise you're just saying here, put stuff in this token without any concept of how it's going to be consumed. If there is no such thing as an OCP verifier application, I don't know how we like what is the point of writing a spec of what goes into the token?
So I agree with you right now. Like you, I agree with you on one point. Like you, even if it wasn't, you should start at one place, right? Like if like it's a problem of the chicken and the egg otherwise. Like you should start with some, and if you need then a verifier, you can add ads. You can also add a spec for the other. But my main point is that there is already a spec that is coming up, like is a graph, like in this getting like into probably will be soon become an RFC, which is the Corim spec. The Corim specification met as already the measurement in a commit format, and the commit format and the consistent evidence binding is basically the same thing. The consistent evidence binding wraps around a commit. So the verifier, a verifier that wanna just be dumb and just looking at one-to-one comparison of the measurement, looking at the Corim, inside the Corim, you can look at the consistent evidence binding and just finding for the dual measurement reported by that tester. But yeah, there is not a formal, yes, there is a RATS verifier, a spec might hint to that, but if you look for the OCP verifier spec, might not exist. And Jeff, I'm asking you, do you maybe we can add a paragraph in the OCP attestation, see how the verifier should consume those?
That seems reasonable.
Matt, will that work?
Yeah, I just want to make sure we're not like throwing statements about what belongs in the token without any concept of where any of this is going.
Yeah, I think as attestation spec, we can filter going down and not limit out to only what that tester should be doing, but we can also including what the verifier, how the verifier shall consume this token as another paragraph. So we will close the picture. And we make a reference to what also the RATS specification is hinting on how to consume those. So any other questions?
So I had a comment on the certificate chain in the EAT. So one of the trends for OCP security is getting rid of device flash or non-volatile memory. So we've got things like the flashless boot spec, where, you know, as much as possible for security reasons, you know, we don't want non-volatile memory on the device. So for like the certificate chain, under those constraints, it seems like for the certificate chain, the responder should only be providing those certificates that it dynamically generates, like on boot, so like the DICE certificates, and then all of the other parts of the chain from the root CA down to the, you know, intermediate certificates should be off the device.
That will make total sense. This is something, that's why here I put should be the root CA, but and also need to be, this should be kind of like also closed even with the SPDM specification, because as of now, the SPDM, and this is something I always brought up, like I remember even in the Calyptra work group, I brought it up once, and it's something that I don't think that this is colliding with the SPDM specification. The SPDM specification right now require in all certificate model that the first element in the chain should be the root CA. But those from the root CA to the signer or DIDEV ID, the chain is static. So there is no reason why it should be provided by that tester and not the verifier could already be provisioned with that one.
Yeah, I brought that up in SPDM as well. So
okay,
So I guess for Jeff and Brian, like, does that sound reasonable? Like, it wouldn't even be should be the root CA. It would be like element N should be, you know, the IDEV ID, or, you know, whatever gets generated on the device. And then it's the requesters or the verifiers problem to patch in the rest of the certificate chain, the so-called static part.
That seems reasonable to me. I'll let Brian speak to that. But also, it seems like there is missing some guidance, perhaps, on how the device, the cloud service providers, PKI mechanisms, and the customer's verifier all work together to make sure that the right certificates are conveyed at the right time. I can imagine cases where you issue your own certificate as a CSP, and you would like to just, you know, you could just provide that to the customer whenever they need it, but like they need to get something from the device. So you need to then push it down to the device just so it can hold it and give it back to whoever asks it, which is the whole flow.
Yeah,
It
that
seems
ties
like
in.
there's a lot.
That ties into what Matt was saying about, you know,
Yeah.
a verifier spec that could be brought into a data center infrastructure spec to support
Yes.
things like this, where how do you tie, you know, secure sessions to attestation to certificate chains, all of that. Because right now we're putting the burden on the device for a lot of it, and that means more non-volatile memory. That means more complexity in the device, when ideally that would be offloaded.
Yeah, and another challenge I think in that is the cert slots that are in like USB, and, you know, it found its way into SPDM. There's no standard around that. So like if you have device A, what's, you know, slot 0 versus, you know, slot 1, 2, and 3. So that's an open. And then I don't get the part here where the root CA is always, you know, something offline, whether it's a CSP root CA, or whether it's a device, you know, manufacturer root CA. That's always a thing that's separate from the device. You know, the device typically doesn't have a root CA. It has like an intermediate, but the root goes back to the device manufacturer. So I don't get the part where the root CA is element N.
I mean, that's in the SPDM spec. The full certificate chain should be on the device.
Yes.
I tend to agree with Brian. There are things that are not very specified, you know, especially in terms of the hardware supply chain, where you may have an ASIC or an SoC from a vendor that moves into becoming a device, and that device becomes, let's say, going to a data center, and how those certificates are you know, used in the SPDM slots, populated, and, you know, which one becomes the top of the chain for dice. That is something that is left to the designers, I would say. So it's under specified. I don't know if that's intentional, but it is at this point.
So what I'm thinking right now, like, I agree with Brian and with you, like, and I agree with that. I think there is a general agreement here. There should not be the root CA here. There is no reason why the device should report the whole certificate chain. One thing I wanted to highlight, as Stephen also mentioned, is that right now the DNTF specs prescribe that. And for this particular profile, we want a backward compatibility with SPDF 1.2. The question is more for you, Stephen. I'm sorry to put you under the spot there at this point. Would it be possible, when you said there should be the device CA, will this be in alignment with the DNTF SPDM 1.2, or we could like it would be possible, even like my question, like, let me rephrase differently. Would it be possible also for SPDM 1.2 to only report a partial chain, or you will get out of spec at the point?
Yeah, 1.2 can't do that.
Okay.
So SPDM, for some reason, SPDM allows only the root CA to not be part of the certificate chain returned by the responder. So the responder is free to return the whole certificate chain, or it can like omit the root CA if it wants to, but it can't go any deeper than that. So if you have like 3 intermediate certificates, then those have to be there. So SPDM went a little bit of the way, but not fully. But yeah, if SPDM does do that, it would probably be a 2.0, SPDM 2.0 type of thing.
So you don't even envision 1.4 can go that far?
I mean, we can discuss it, but yeah.
Yeah, that tends to get complicated due to compatibility concerns.
Yeah. And then, I mean, even going further, like if a responder is not doing DICE, then like the responder could like just, in theory, could just provide its like public key and a URL to the requester, say, here's my public key, here's the URL, go find my certificate chain out there. And then that would really cut down on the flash.
That's a good point.
Sorry, one point. So we can define which intermediary is the root, right? You don't have to use the real root, right? Why do you send the whole cert if you just say one of the intermediary that issues the device ID cert is the root? Would that work?
I think for the root CA should be quite, sorry.
Yeah, isn't the root usually self-signed and the intermediates aren't self-signed?
There's a path length parameter too.
For SPDM, you just need a hash of the root cert in the search chain report, right? Meaning you basically only need a public key of the intermediate cert in the verifier. Whether it's self-signed or not doesn't impact how you verify it, right? You only need a public key.
I mean, yeah, SPDM itself doesn't really define what a root CA is. So yeah, that's true. You could interpret it that way.
Gets dubious when you want to actually do like search verification to check like that it's not an expired CA or it hasn't been revoked, and you want to do a whole CRL business.
Right, the root cert probably couldn't be revoked. So another question here. This search chain shown here, this is inside the CWT EAT token, right? Why would it have to follow the SPDM searching requirement?
Oh, that's a very valid question as well. You don't have to. You can even like it. That's why Steven suggested to be device CA, and I actually agreed to that. I can make this like, and the reason why initially to root CA to have parity with SPDM specification, trying to diverge. But what Steven, and I wasn't aware that also SPDM is going to that direction with 1.2.0 probably. Being more flexible on the length and the depth of the certificate chain that need to be provided. At that point, I don't see any issue why we need to put a root CA. Yes, and I agree with you. Those are completely decoupled.
Okay, good.
So I guess the problem is if you don't include things up to the root, how do you make sure the verifier has all of the intermediate certs it needs to validate?
Yeah, that's on the requester and the verifier. So if the verifier wants the full cert chain and the requester only gets part of it, it would be up to the requester or somebody along there to get the other parts and then do surgery onto the unprotected portion here. So they would have to insert the root CA and the other intermediate CAs into that X5 chain claim.
I guess my concern is that, like, when you're talking about an SPDM requester, I don't know how it's going to do that, right? Like, you don't
Yeah,
necessarily have just one chain from root to intermediate that issued IDEV ID certs. There could be many different intermediates, sets of intermediates for different devices. Like, not every device of the same type necessarily has the same intermediate cert chain. So you might have multiple intermediates issuing IDEV ID certs for the same class of devices. So just because you are requesting certs from the same device in the same data center doesn't mean they're all going to share the same intermediate cert chain.
No,
Yeah,
but
the cert, the intermediate certs are in the URL, right? It's in the cert, like authority distribution point, something like that. So there's extension that shows you the issuer cert, right?
yeah, and I want to also add up one other thing, that with this spec, like as we said, like at least for 1.2, the request to be valid need to be signed by SPDM. So what I mean is that the requester must ask the get certificate chain from SPDM, and the get certificate chain from SPDM from 1.2 must be rooted in the root CA. So since you need to retrieve that information anyway, will be valid to get to the device CA, because there will be a point of contact between the device CA that is in the seat and the get certificate that is in the that is retrieved when you do get certificate chain from SPDM itself. If that makes sense, Matt. Like when you do get certificate in SPDM, like you must do it at least for 1.2, because the request must sign.
For 1.2, I get it. I guess if we're talking about not chaining up to the root, it becomes an interesting problem for how does the requester know what it needs to go fetch, and how does it do that if the device can't provide the whole chain?
Yes, and if it makes sense, I will kind of like decouple for this itself, but I think that is an interesting topic and must be solved anyway. We can decouple from this, Matt, if you're okay, but I think that we can take it as a verifier when we provide verifier recommendation how to consume this it. We can discuss about more on this, but also in the other aspect, if it makes sense.
Yep.
So one thing, since we are 5 minutes away from this, like from the top of the hour, I have a couple of questions for you. First question is like, if there are no major disagreement, if you're okay, I'll start documenting this at the beginning of the next year to the OCP attestation spec, as I mentioned before. The second question I had is that if you everybody okay, I put a couple of statements already in the OCP attestation spec. Jeff, I mentioned to you, will be possible to start merging those into the main spec, like just sealing that we are like OCP. Basically, what we are saying is that OCP attestation spec will have either a RATS or a TCG manifest as attestation report.
Yeah. In fact, like we have 5 minutes. I could just do them right now.
Yeah, I will love that. And as we move forward into the next year, I will add the other portion of the spec, including this.
Is there a reason why we would choose one over the other instead of both?
The TCG manifest over the. So here is that's a very valid question, Brian. The why both? Like the reason why we wanted to do the TCG manifest initially is that we are still defining how the RAT seat should be defined versus the manifest itself. It's already self-described by the TCG specification. So someone could even implement it right now if you want to do it. Versus the RAT seat will still are, like you say, discussing and describing the specification, how the profile will look like.
But why not get it done and then switch it? Like it takes device manufacturers a long time to adopt stuff anyway. So instead of having both, converge on one, but wait till it's ready.
So you only want to eat, that's what you're saying, and removing the manifest?
Well, what you're saying is TCG is ready now, so let's include that, and then let's transition to ETH later. And what I'm asking is there value in doing that intermediate step? Why not either just wait till ETH is ready? Like, is there something broken today that gets fixed if we just put in TCG manifest and ETH later on? I'm not quite following why we would choose both. You said it's timing, and my question is, what if we wait?
So yeah, valid point, Brian. My point is that we can include the manifest right now because of the manifest and the ETH will have the same, internally will have the same consistent evidence. So the way we are still reporting the measurement in the same environment map or measurement map format. And with the TCG manifest, so we kind of like you're reporting kind of like the same thing. And we are using the manifest as a stepping stone towards what it can be the ETH. And that's what I'm thinking. If you want to wait for the ETH to be ready and just you say the ETH is the only valid one, we can do it. But we really want to do that, or we can start with the manifest. Like it will be. I don't see any issues to keep both as available option, as both of them will at the end of the day will represent the measurement in the same format.
I see. So you're saying it's incremental, so there's value early on in getting started.
Yes, it's really incremental.
Got it. Okay.
So should we go and look through these changes in 2 minutes, or let's see. This one
I would
says
think maybe put the changes in and then let folks review and comment.
okay. So the changes are here, like they're just proposed.
Oh, awesome.
So we just need to say like, and these haven't changed since we last looked at them on the call. So it's just a question of can we just accept these changes so now they're part of the mainline draft. Like, for example, I guess this one revs to 1.2 because we need features in 1.2 to report the ETH.
Yep. In the manifest itself, there is 1.1. You don't have a really way to report the manifest.
Okay. Anyone have problems with revving to 1.2?
No, I think that's goodness, actually.
All right.
Yeah.
Attester devices shall provide an attestation report in either RATS EAT or as evidence manifest TOC. Is what we just discussed, and there's value in moving forwards here. Attester devices that do not just accept that, that do not provide a measurement manifest shall locate RATS EAT at hex F0, which we discussed today. Any issues? Okay, hearing none. It is merging. It is not. This is final. Like we're not. This is still open for comment. Feel free to comment, but I'm just going to merge.
Thank
changes.
you, Jeff.
Okay. Is there any other changes that you've proposed before that are not yet merged?
Not really. The only thing I wanted to say, Jeff, that you deleted like the VCAS requirement for SPDM in the suggestion, and that's like in the required command you deleted like the version capability algorithm.
Oh yeah, because those are just required anyways. Yeah.
Yeah, the spec mandatory won't say you send those ones.
Oh yeah. So okay, so these were deleted because like it's not useful for us to also say they're required. Challenge deleted. Don't think we need it. Digest don't need it. All these things for sessions, like we only need these for TDISP, and if we have TDISP, we'll have these anyways, so it's not really useful for us to call these out as required again. So, any arguments against deleting these?
No arguments. Like my only arguments was only the first one for version capability and algorithm, because it's required by the SPDM spec that you must send those commands.
So, but you're okay if we delete these here?
Yeah, not remove. Yeah, not deleting it. I want not those to be deleted because the SPDM specification. Yeah, there's the other way around. The SPDM specification requires that you send those commands before initiate anything else.
That's true, but then like, what's the point of us also saying they're required?
Okay, I see what you mean.
So I think it's useful for us to put down things we want, where like SPDM specs is optional. We really want it, so we'll put it here.
Okay. Yeah. The only reason why I highlighted this was because those are not optional. But since I agree what you're saying.
Yeah, that's the point. Yeah, they're not optional, so yeah. Okay.
I see.
So I'll just do that. Get digests. Get challenge. Again, as I go delete, if everyone has comments, feel free to put them, but I'm not hearing any objections, so. We will discuss get CSR sometime later. We are at the top of the hour, so past the hour.
Thank you. Thank you, everybody.
All right.
Thank you, and have a happy holidays, everyone.
Yeah. When do we reconvene, Jeff? Is that
next one is, I believe, on the 7th.
Sounds good.
And I don't have a solid agenda for that one, but I have something I could talk about. So, but unless anyone else comes up with something, then yeah.
Maybe get CSR.
Okay.
All right. Thanks a lot.
Thank you.
Yeah.
Bye.